Hey, welcome back to the Secret Underground Lair. New shop coat, courtesy of John. Thanks, John. So continuing work on the Bedrail CNC, a suggestion from comments a little earlier from the last video was perhaps step you through the process I go through when designing 3D parts and how I go about the design of it and actually build it. So I did go ahead and I printed one part off here and a prototype of the second part. But I'm going to step you through everything that I go through now to make some parts for this, I'll call it the Y rail mechanism. So that's today's adventure. I'm going to have a single motor. And this is a larger than the two that'll be used on the y-axis or the x-axis. So this single motor will be mounted over here somewhere, kind of like this, with obviously a pulley on the end. And we're going to use a belt. I'm using a 10 millimeter belt. Of course, this is just a piece of a belt. And the belt I'm going to use is obviously going to be longer, but this belt will be fixed onto the sled at this end, probably with a little tensioning mechanism like you saw there. So that'll be mounted in here. The belt will come across to our stepper motor, around the pulley on the stepper motor, then back through a pulley here. So let me just kind of draw a little line on this so you can see what I'm doing. So the belt will come along here, around the motor, the pulley on the motor, over here to a pulley, around that pulley. I just draw that circle there so you can see where the pulley is, and then down the side. So the belt gets attached here on the sled, goes down, around a pulley there, around a pulley there, and back down through here, to this pulley, over to the motor, and then back to mount here. So as the motor spins, it'll pull the sled back and forth. So that's the plan. The step now that I need to do is design the bracket here that will hold this stepper motor and this pulley, which means I need to have something that's going to be sitting out about like this to support the motor. It's going to be about 60 millimeters by 60 millimeters. And then I'll probably want to build some sort of offshoot like that to keep all these things together and be able to capture that pulley. And of course, I need to have the ability to mount this mechanism, this whole thing, this apparatus, down to the table itself. So the holes that are used here to mount the motor, the stepper motor itself, will go right through this so that a bolt will go through the stepper motor, through the bracket that we're going to 3D print, and through this plate. So it'll be held down in 4 places here, and we'll probably put another hole over here and a bolt through that just to keep this in place, that pulley in place. So I'm just going to make a few measurements here to make sure that I get this right. So here's a transferring this rough sketch onto paper. This is what I'm working with. This piece here being representing this rail here, or the bearing bracket for the sled. I have enough clearance that if I put that belt 25 millimeters, this is the back side of the belt, 25 millimeters from that rail, I'm going to have enough clearance to get by that bearing bracket. So then moving down this section here of the sketch representing what I've got here, though not exactly to scale, And then I can take this back to the computer and start drawing up a part. So in this, what I use for a tool to create parts is FreeCAD. And in this instance, what I'm doing is just create a new body, a new part, and then create a sketch on an XY plane. Start by making a simple square and then set the dimensions of this to be 60 millimeters by 60 millimeters, centering it on that on the crosshairs there. That makes it a little bit easier to work with other parts of this product. Then making that little extension that sticks off the side to support the pulley, just making some rough layout lines. I wanted the end of it to be rounded, so I created a semicircle there. Had a little bit of trouble making the semicircle stick on that bottom right corner of that, but getting rid of some excess lines. And then, yeah, just fiddling a little bit here to get that part right. I know that center of that pulley has got to be 40 millimeters from the horizontal line and 44 millimeters from the vertical line. So I finally got all that set. Here you can see me fiddling a little bit trying to get these 2 points to align. I finally realized what the problem was. It had to do with some symmetry. So I fumbled around a little bit here to get that correct, but in the end I got it. Then once I had all the layout lines correct, I just started applying the dimensions that I want to have on this part. Nothing really magical here. I'm just kind of picking things that I felt looked about right. Of course, making sure bolt holes are in the right spot and the pulley center of the pulley is going to be in the right spot was important. But I just arbitrarily picked a 45-degree angle for that little pulley bracket to stick off. The dimension of the little spur where the pulley is going to sit, that was just kind of picked arbitrarily, just kind of looked about right. So nothing terribly magical about what I'm doing here in terms of specific dimensions on the part, other than it seems to look about right. And once I had that basic shape laid out, the part was, that's all I need to do before I can now extrude that part and make it the right thickness. So that's what's happening here. And I initially raised it up 20 millimeters, but realized that's the exact length of the shaft of the motor. So I added another 2 millimeters, extruded up 22 millimeters. So there will be a little bit of a clearance between the bottom of the shaft of the motor, or between the tip actually of the shaft of the motor and the plate on which this whole bracket will sit. Then put in the 4 holes that are used to mount the motor. Those are 47 millimeters apart in both directions. Made them 6 millimeter holes to accommodate the 6 millimeter bolt. Then I'll go through it all, get them all centered and aligned around the center hole. This is where centering the drawing itself on those crosshairs really helps, makes a big difference to get everything squared up. It just makes it a lot easier to work with the drawing this way. So having got the 4 bolt holes put in place, I can then create the hole in the center. The stepper motor itself has a little bit of an embossment on it, and I thought, well, I'll make the whole thing that big when it uses less plastic to print and lets the motor sit down in there nicely. So that's what that's done. And then, of course, then the hole for the pulley that goes off on that arm. So once I have all those holes marked and placed where they need to be, I can then use the hole tool and create a pocket through all of those pieces, and there's our basic part. The next step in this piece is creating the holes through which the belt will pass from the sled in, and this is the view now, so I'm going to cut a little hole here where the belt will come through from the sled to the motor pulley, and then I need to make another slot where it goes around the motor pulley and out to the pulley, call it the idler pulley on the far side. So this is going to be 15 millimeters in height, made it 15 millimeters in width. Again, just picking numbers that are rough, they're ish. There's no magic to this. So that's the layout of that hole, and then we'll punch it out in just a second using this tool. There we go. Make it the right depth so it goes all the way through. I then discovered that this hole should actually moved over a little bit to the right, so that we will come in and actually hit the side of the pulley. Right now we're going to hit right about the middle of the motor shaft, and that's not going to be right. So make a little bit of an adjustment on this piece. The next bit is providing a path for the belt to go from the motor shaft around the idler pulley up on the top right corner there. Now to do that, I'm making a sketch, and again, this is almost freehand to do this bit. So I know that we have 5 millimeters from the center of the motor shaft to the outside of the pulley, and we got 5 millimeters from the center of that top right hole, 5 millimeters to go around the idler pulley. So I'm just creating sketches here. These two circles just represent the pulleys themselves, and then I'm going to draw a line kind of roughly intersecting those circles, just so that I get an idea of what I want to cut away on this portion of the arm to accommodate the belt. So again, these are just kind of construction lines. The tool actually does have the ability to make construction lines, but you know, that's a nicety to have. I'm just using these. I'm going to get rid of them in at the end of the drawing here, but I'm using these as guides. That's all they're there for. So having those pulleys kind of laid out, I can now determine where I want to cut away for the belt. And I'm creating a sketch on top of the part right now of the portion that I want to cut away, but that's going to be, I'm going to offset that a little bit from the surface when we make the final cut. So bear with me while I make this little square and get it lined up roughly where I want it to be and permanently fixed. So with that sketch now laid out, I'm going to offset it a little bit, 3.75 millimeters from the surface of the, sorry, now I'm just getting rid of those circles that I had there. Now I can offset the sketch a little bit, and then when I create a pocket, it's going to be taking it from the middle of the part. So I offset it just by 5 millimeters to begin with. That was a mistake. So I went back, changed it to 3.75 millimeters, and made it a 15 millimeter pocket. And that gave us what I'm looking for. The next bit is creating a pocket for the pulley itself. So I'm going to go through the same kind of process, create a sketch on the top surface of the part. I think I made it about 20 millimeters, just 25 mil, I can't remember, I made it big. And then again, offset that by 3.75 millimeters once it was set where I wanted it to be. Again, I have to make sure the dimensions are right. So here we are offsetting that sketch by 3.75 millimeters. And then I can pocket that 15 millimeters, and we have a nice part. So that's the basic shape of the part done. The last thing that I like to do on pieces like this is just kind of give them a fillet, kind of round off the sharp corners. So I'm just kind of lining the part up here so I can get to those bits and just round off the corners. And now, of course, the final piece for this, or final part of using FreeCAD, is to create a mesh for this shape. And the mesh is something that can be exported into a 3D printer slicer. It creates an STL diagram out of this part. So that's what I'm doing. Just highlighted with the part highlighted, I'm just actually I just saved the part. Now I'm going to create the mesh, and to do that you create a mesh, select the mesh tool, say yeah, make a mesh, and it makes it. Just kind of click, click, click is all you have to do here, and then finally export the mesh. And once it's been saved as a file, I'm finished with FreeCAD, and now I can go into my Cura slicer, load in the part that we just created. So the part is now placed on the print bed. I just want to make sure that this part is printed with supports. Frequently when I'm printing part, I don't use any support material, but since we have these little gaps in the part to accommodate the belt, and for the gap over here to support the idler pulley, I want to make sure that we get supports. So by turning on a preview, you can see the support material being printed in these two areas here. So happy with that. I can now export that part and take it down to the 3D printer. And here's the print in progress. Finally printed. I apologize if the camera drifted down during that print, but cleaned out some of the support infrastructure. Of course, there's a little bit more cleaning out to be done, but that's how the piece will be sitting on the work table with the stepper motor in here and the belt coming in around, and pulley will be mounted in here. So that's going to be it for this video. Thank you very much for watching. Please like and subscribe. I will see you on the next video.